All right. Well, hello everyone. Hope everyone's here. Hope no one had trouble getting to the stream. Um, just a couple things to take care of first. One, make sure everyone's checking your email. I've sent out schedules for this week, information about the stream, etc., as well as on your school emails, the slide decks for tonight and all the meetings are available to you to look at if you have need to reference information from it, or just want to look over it again. Maybe even during build season you're like, oh dang, how did I do XYZ, or how was X explained, how I should do that. You have access to the PowerPoint, you can go look it up. All else fails, I mean, yeah, I'll mentor will still be around, you can ask us, but you know sometimes robot work happens at weird hours of the night, and I'm well aware of that. So yeah, check your emails. Also, make sure you go to the Cowtown website and fill out the waiver form out there, because you aren't allowed to go to Cowtown if you don't complete that. It's mostly just releasing Lee Summit High School from any liability if you get hurt or get COVID or whatever while you're there. Um, anyway, also as part of your emails, you got an invitation to Slack. Um, and Slack is, I mean, primarily announcements go through a group me, but Slack is a great way to just be able to talk about things, because, we're not going to be in the shop, especially this fall. We're not going to be there every day. And, even during build season, we're probably only looking at, 4 days in the shop a week or so. And there's enough work that there's probably plenty to do, in Onshape or in, programming or business outside of meeting times. So that is a good way to collaborate, outside of shop hours. So, you know, effective communication is very important, being able to share, links to websites with people about, where to download, the software that we need to, do programming, or, hey, where's that part that we need to buy to put on the robot? Having effective communication like that is good. Um, so Slack is a great way to do that. If you guys have used Discord before, it's a lot like Discord, just without the, hey, it's optimized for like professional, like work type stuff, and the voice chat. It exists, but it's buried in there, and people don't hardly ever use it. So it's available on Windows, Linux, OS X, Android. It'll run in your web browser, iOS. Primarily, there's going to be screenshots about certain things you can do in it later, and those are primarily going to be in Android or Windows, because that's what I run. Sorry, sorry, kids, I'm not going to go buy and Mac just to do a tutorial. So getting an invite, we have your school address, and we have already sent you an invite. Be sure to check school email often. For the first time since the alumni have kind of taken over this program, we've got distribution lists to send you guys emails for stuff to make that convenient. So we're going to try to be more communicative than we have in the past. Mentors, just give us any email. It doesn't have to be your student email. You need an invite to Slack. Join channel. So once you're in Slack, there's an add channel button when you can see the channels list, and it lists out every channel that exists on the server. And you only have to join the ones that you're interested in or have permissions for. Oh, hold on. Sorry, I have two PowerPoint windows, and I was advancing the wrong one. So yeah, Slack is available on Windows, Linux, OS X, Android. There's the Wikipedia article for it. What I was discussing earlier about, students and mentors, how to get an invite. All right. So now that you can actually see the screenshot, there's this add channel button. And my stupid PowerPoint thing isn't updating. Hold on. Technical difficulties here. Sorry. Really? Okay, well, there's more than one way to do this. Display capture. All right. So now that you can actually see what's going on, let me backtrack a bit. All right. So communication, that slide, yeah, Slack's available in a bunch of places. Get an invite. All right. So there's a add a channel button. So you can, that'll bring up this up here where you can get every channel in the server. You can see it if it exists. Yes, we do have a super secret mentor chat. No students, you aren't allowed in there. Sorry. Um, and you can set up per channel notification. So, say you are primarily a fabricator or a design student, you can have it to where it notifies you for every message in there. But, say you want to see what's going on in the programming channel, but you don't want to get notified every time, Dylan sends an email or not sends a message at like, 7 p.m. at like, hey, go look at this thing. You can hold that button there. It'll bring up the channel details. And then you can change your notifications on a per channel basis. And there's that little mute channel slider. You can just mute it. Now, if someone at mentions you, you'll still get pinged, which is good. But oh, hi Gavin or Garvin, Garvin the Puny. I assume that's Gavin. But yeah, so and you can see who's all's in which channel. We have a few apps on there. I probably won't go too much into that. Recommended would be to set every channel you're in to notify for every new message except for off topic. But like I said, if you feel like you're getting notified for things that don't apply to you at all, feel free to mute the channel and then we'll just use, you know, here and other things to, actually get people's attention when we really need it. The desktop version of Slack, you can have email notifications, preferences, notifications. Scroll down to send me email notifications for mentions and direct messages. And so you can have it to where it forwards, notifications to your email if you need, more layers of getting notified about something. Slack supports custom emoji. We have a bunch of custom emoji. If you want to send me more emoji to add to the server, that's cool too. You can hit this thing here with a little plus on it, and it'll come up with an emoji menu. You can pick your emoji. You can also do colon, name of emoji, colon, like Discord, and get your emoji that way. We have and you can see in there, we have emoji for like different robot parts, different teams. So like if a lot of the Kansas City area ones, I'm pretty sure I added. So like we could even talk about what alliance we're picking with emoji. If we really want to. Um, not standard emoji. Yeah. So. Oh, and Slack's custom emoji is completely unlimited. They don't have slots like Discord. So we can have as many custom emoji as we want. Obviously, they all have to be school appropriate. So, you have to submit them to me first before they can be added. But the option is there. Oh, yeah. And there's some weird size restrictions 128K. Um, 256 by 256, etc. Um, so Gavin just gave me a great example. So this is the media channel. You notice there's a topic up here. This is all. Let me just change that a little bit. And delete that. See, we've got a chat for that. It's called, not that one. Off topic. Off topic would be a perfect place for that image because I have off topic completely muted. If you start posting, you know, things that aren't appropriate for school in there, I will delete it. And if you do it too often, you will get suspended from the team and potentially lose your, lettering. So don't do that. I just said random weird images don't go in media. They go in off topic. Media is like pictures of robots or pictures of the team or stuff like that. Right? So that's Slack. That is the first bit of this lesson. Now let me open the better, cooler PowerPoint that isn't just a tutorial on how to use a chat surface. So we actually want to get into actual robot stuff. There we go. Nathan's got the idea. Oh wait, no, you can't get mod. Sorry. Uh, Git will be another lesson. Let's see if this PowerPoint actually wants to work right. Yes, it does. Okay, I thought I had that more muted than it was. Hold on. Wait, hold on. I'll all right, so yeah. Anyway, the actual robot stuff, the design process. I know a lot of you have probably taken the Introduction to Engineering and Design class and already seen something similar to this, but it's a good refresher because even when you know the process, sometimes you forget that you need to apply the process or that it, actually applies in the real world at all. So, design process, it's a lot like the scientific method, which if you haven't had the scientific method taught in science class, well, I don't know what to say to that. But hopefully everyone's, done the scientific method and realized that's, question, research, hypothesis, experiment, conclusion. It's pretty similar for the design process. It's just instead of like a question, you have a problem that needs to be solved. And instead of a hypothesis, you make a prototype and try it. An experiment is just testing your prototype and evaluating it. So the problem, you need to define it and have like if you define your problem incorrectly, you're going to design something incorrectly. If the problem really is how to score a power cell in the goal in, say under 2 seconds, and you define it as how do I just shoot a power cell out of my robot? You're going to build something that just meets that low bar of getting it out of the robot. It needs to be able to get it into the goal. So, when you are making them, there's something called SMART, an acronym for your goals: specific, measurable, achievable, relevant, timely. You've probably heard this before. If you haven't, it's just that, your goal is one thing, you can measure it, it can be done. I mean, a goal that the robot should be able to get across the field in 0.1 seconds is not achievable because we don't have enough power from the battery to like physically move the robot that fast. So that would be an unachievable like drivetrain goal. Relevant, it needs to make the robot good at playing, the goal that you're setting for a robot needs to make it good at playing the game. And timely, something that can be done in 6 weeks. And so there's a set goals link. Bring it over here. So, John V. Noon is a very smart. I think he's a current mentor, but he may be a former mentor now because he changed jobs and maybe moved. Of Team 148, who has won the world championship, I don't know how many times, like 3 or 4. Um, so he has a blog at johnvnoon.com. Actually, a really good blog for FRC stuff. And, basically just, talking about how they set goals, challenge, focus on goals, challenge convention, continuously improve, always be testing, a good article here. You can see I'll post the link in the chat. RC 5454. But yeah, so process rules are there. Um, I'm not expecting you to read this right this second, and we're not really going to go over much more than just saying John V. Noon is really smart. If he says something, it's probably right. We've used his design calculator for gear ratios for years. So he's a good external mentor to use as a resource since he puts so much out on the internet. So, like, an example of a full robot goal would be 1806 will be able to pick up power cells off the floor with minimal involvement in alignment. You know, not not exactly smart, but that would be close enough that gets the general idea across. You know, for a specific subsystem, the intake will hand off the power cell off the conveyor within 3/4 of a second of coming in contact with the power cell. And that, I missed an end quote there, but that just kind of goes back to an idea on intakes that you should be able to touch it, own it, which I think was actually coined by John V. Noon. That the idea is that, as soon as your like game piece picker upper touches whatever game piece, it should be yours basically like that. Like snap your fingers, it's yours. Not, you know, sitting there on top of it for 5 seconds, shaking the robot back and forth, trying to pick up a game piece because that is one of the most common actions in the game. It shouldn't be difficult for your drivers to do. It should be easy and repeatable. Strategic design. This is basically another slide where I promote another first mentor, Karthik Kanagasavathy, which I probably, and I have to apologize, I probably just absolutely murdered the pronunciation of that. He's an 1114 mentor. He's like on the game design for Vex Robotics. He does a lot of really good stuff. He's got a really good presentation for like effective first strategies. You guys have access to this document that I'm sharing, so you should be able to see it if watch it all if you want. I recommend it sometime before the start of next season. Watching that because it is a really good presentation. I actually recommend, but like maybe after Cowtown, but before the season, finding some time to watch that. So you define your problem through strategic design by. Actually, let me explain what strategic design is. I kind of skipped over that. So you look at like game act. You read the manual. You figure out what legal actions your robot can take to score points, and you look at them on the points per second basis, almost like damage per second in a video game. You want to look at what actions will get me the most points, because we have limitations on the robot: weight, resources, time. Like our robot can only do so many things, and even fewer well. um you know I'd say we're kind of in a weird place on resources, whereas we have tons of manufacturing equipment. We have a plasma laser, we have a CNC like laser for polycarb, we've got a mill, a lathe, drill presses everywhere. We can weld. Like we've got tons of manufacturing resources, but where we're constrained is people resources and time. So it's going to be very interesting this year to see if we can realistically pin down what resources we have and make a good robot. The jack of all trades is the master of none. Unless you're a team like 254, us some years, 148, 118, they can be the jack of all trades and the master of quite a few of them. But, again, it's going to be really interesting to see what we're going to be able to do. Research. Steal from the best, invent the rest. Team 1670 hates like one of their team mottos. At championship, there's a thing called Einstein, which is like you already qualified for Worlds, which means you probably won an event or some award that got you to Worlds. And then you have to win your like division at Worlds. And if you do that, you can go play on Einstein with the best of the best. They're on Einstein almost every year. And so, we don't have to reinvent the wheel every time we design something. We should be absolutely looking at what other teams have done in the past and trying to, we can kind of copy their design. But look, we're smart. We can take their design from the other year, optimize it for this year, and maybe even look for ways to make it better, lighter, nicer, etc. TheBlueAlliance.com is a really good resource. I'll actually have an entire lesson at some point on how to use this. You can literally just type in like a team number, go to their page. You can look at their like team history and look at all those banners they won by stealing from the best and inventing the rest. And how they were, on 19 Einstein, 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 Einstein. Like, don't reinvent the wheel. Also, just, for reference. For reference, we're no slouches, but we have never been to Einstein, so we should try to fix that. Um, Chief Delphi is a forum. I don't necessarily recommending posting on there because it's really easy to get just like I don't know, for people to look down upon things that you post, but it's a good resource for finding white papers and people like explaining, like how they do things, etc. You do random Google searches for what you're trying to do because sometimes we copy first teams, but sometimes it's just like some random guy did a thing in his spare time, and we can kind of use that as a springboard. Many teams have their CAD posted publicly on Onshape, and in fact, if they want to reuse their CAD, they have to have it publicly posted. So you want to, if you have a robot that you really want to look at how something worked on it, you can actually just go pull up their CAD drawings and see, exactly how did that work? What was their design? Um, yeah, teams have websites. You can find them through Blue Alliance, um, and they'll have their cat on there. Teams will just have their code, publicly posted on GitHub. And again, if they want to reuse their code, which is a really good idea because things like drivetrains and like flywheel shooters get used over and over and over again. The basic design of it. It's on GitHub. Business documents. So, the reason I'm doing this at the all team meeting and not just the design meeting is that, whether you're a programmer or a business person or just, the actual robot design team, you're designing things, whether it's a business document, whether it's a piece of code, like that all takes design. Prototype. Like a prototype can, come from a sketch on a napkin, cardboard aided design, just like draw it out on cardboard with a ruler or, cut it out, see if, the dimensions um, work. Plywood. We have a CNC laser. You can, quickly CAD something up and cut it out of plywood and see if it'll work. Prototype, new for this year. We can take, literally a piece of PVC and a PVC cutter and some self tappers and a drill and put together things like this picture down here. And, hopefully like in a day or less without, any real machining experience. And you can see how they just have like instead of getting our legal motors hooked up to test it, they just have a drill just clamped onto the end of the shaft to spin that. Here they have an actual motor set up. You know, and then a CAD model can be a prototype because you can just check if the dimensions are actually reasonable in the CAD model and animate it. You can see it there. They just they modeled the box and made sure that it fits in their intake. Um, I want to go back to this. Like, actually see here. This was for the 2015 game, and this was 1114's intake prototype. They actually went to Einstein that year, just based off something that was tested, like this, like day, 5 of the season or what? Not even day 5, probably like day 2 of the build season, and that intake carried them pretty much all the way to Einstein. And this video, I'm gonna have to mute it for DMCA reasons, but you know, they prototyped their entire robot out of plywood before building it. And this plywood robot that they made a hilariously memey video about, probably would have beaten a lot of teams' actual robots that year. Like this plywood monstrosity here is a heck of a good robot. Okay, except for the falling over part. But when you make it out of lighter for strength, aluminum, that problem goes away. But they at least see that, yeah, we can shoot a ball into a goal with this. We can, pick up a ball with this, etc. before building the whole thing. So again, that video is in the PowerPoint. I'm not gonna make you watch the whole thing. Prototyping. Oh, yeah, here's one.
What we have currently, what you saw in the render on the last slide.
So this is like their ultra early practice robot. I mean, you can see it's just like Lexan riveted together. Like their actual robot looks a lot fancier and nicer than this. Oh, the black guy in sunglasses, that's one of Team 254's coaches, EJ. So yeah, they made a meme about their coach. So yeah, like they just have their shooter made out of plywood. Um, and they had this together by like week 1.5, week 2 of the build season that year. This was, yeah, in 2020. Fortunately, didn't really get to compete that much, but you can actually see their. Did they get to compete? They did. They won an event before everything got canceled, but you can see their actual robot, competing over here. Like, an early season prototype doesn't have to be super nice. We just have to get it, nice by the time we compete. So yeah, so prototyping, it's important. We don't prototype, we build, complex things that don't work and put it on the final robot and then go to the event and stink. Testing, use old drills, drill connected to a motor power supply powered mechanism. You can like clamp your like intake prototype to like an old frame and bumpers set up. Um, cycle game through it or attempt to perform game action. Clamp it to a old robot, etc. Evaluating your prototype. So, ideally we make multiple prototypes of like every like manipulator that we're going to have on the robot and actually evaluate how easy is it to make in a professionally, is there another concept that's better, and evaluate them, objectively, because it's really easy to get super emotional with these robots. We put a lot of time and effort into them. And so, we all want our concepts on the robot, but that's not always what's best for the team. And so we need to, just make the prototypes and then just see how well they do. If, you think you have a brilliant idea and then you make a prototype and realize, wow, this is bad. I'm glad we didn't just go ahead with this. That's the idea. We make a quick prototype and we try to do what's known as failing faster. If we figure out that we screwed up on day 2 of the build season, oh no, we lost maybe 2 days of build. We figured out that we screwed up something on day 2 of build season, but we don't find out about it until we're at competition. That's when things start going bad, and that's probably a great way to miss worlds, is just not prototyping things properly. And I kind of fail faster. That's another John V. Noon quote, of course. But basically this is just showing kind of a general timeline of when things should be done. Also, that we iterate on things, because sure, you can have that one prototype and you need to make the real version of it, but even the real version of it isn't the real version of it until we go compete with it. So we should, always be looking to improve things, make it lighter, make it faster, make it better. You know, complacency is the enemy. And then, I don't expect all of you to understand all of what I'm talking about here, um, but just like some general robot design principles for different kinds of mechanisms. You want your drive-based robot frame to be robust and serviceable. It's a contact sport. We're gonna get hit at some point, with the exception of the year 2015. We're gonna get hit. So the robot frame needs to be able to survive taking a 15 feet per second collision from another robot. If it can't, that's a problem. Um, and select gear ratios for the distances you need to drive. Um, don't gear for 25 feet per second when we're only driving half the field. Really, what's that saying? And got this really cool thing that I borrowed from Team 1678. is we have calculators for this that tell you, free speed, adjusted drivetrain speed. You put in the motor that you're using. It's got all the information in there already. How much current is it going to draw? That's important. You put in your wheel diameter and all that. We've got both gears in here. And this design tool is really cool because it's also got just, gear calculators for, not just the drive, but like intakes, etc. Also got stuff in here for like calculating, center to center distances and like how many chain links you need, belt center to center distances for different pulleys. That'll all be in a different lesson, but this design tool is really handy, and this will be the first year where we have all these calculators all in one place. Look, you can even calculate how many air tanks you need on the robot to not have to charge up during the match. Oh, and keep track of how many motors we're using for different things. What gear ratios, etc. Which is, for the design people, keeping track of all this is really helpful for the programmers because we need to know like gear ratios and sensors for sure. Then like a powered roller intake. Those returning students saw what we made last spring. Um, you know, General rule of thumb: you want the like speed to be double the drivetrain speed. When we if we actually end up making one of these next season, I'll elaborate a little bit more on that. And then what comes up with powered roller intakes is unbreakable versus unbendable. Lexan, polycarbonate, really tough, really flexible. And it'll flop around a bunch, but it'll be really hard to break your intake. Because a lot of times your intake reaches out over the frame, so you just have exposed, non-bumpered like arm. And if your robot comes and sideswipes your intake, you don't want it to just break. Aluminum, is another decent option, but again, you can break welds. It'll flop around a lot less, but repairing an aluminum intake is a lot more painful. Auto centering, you don't want the driver to have to be really precise in lining up with a game piece. You want them to be able to just kind of drive in the general direction of it, and the robot be able to pick up the game piece. And I've got these good examples listed here. You can look at them when you get a chance. Elevators wildly vary. There's some examples. Team 254 makes some of the best elevators. So if you're making an elevator, probably look at some of their old robots. Cascade versus continuous is a thing. Blow up this PNG. Um, you know, Cascade, it'll like kind of go up or wait, continuous, it'll kind of lift in order of like this section, then this section, then this section. Continuous, they kind of all go up and all your stages kind of go up together, which makes it a lot easier for like programming a PID to, well, it makes it easier for the programmers. Um, um, Climbers, strong elevators an option, hook, delivery, and winch. 118 actually made a grappling hook in 2016. I don't know if I recommend that, but it was cool. In Team 1986, which was released Summit West in 2018, actually had some wings that came off their robot, where other teams could drive onto their robot and they could pull them all up so they could all get the climb points. Pay attention to effort versus reward. Climbers can sometimes be really hard. Climbers can sometimes be like stupid easy. And, first has a real challenge balancing the points with that. So, there's going to be years where everyone needs to have a climber, and there's going to be years where almost no one needs a climber. Um, you know, Climber alignment is important. You don't want it to be difficult to align with whatever you're climbing on. Ideally, you want it to be fast. But, sometimes there are diminishing returns on being, a 7-second climber versus a 5-second climber. Now, our climber in 2013 took like 30 seconds. That might be too slow. Roller claws are a thing. I'll actually pull up a picture of this. Hold on. So that's a roller claw, a rather large and extreme example of one. But let's see that match that we're kind of like stuck. I have to mute this again. You can see them back here. They're playing goalie. That's kind of not what we're interested in. At some point, 11-14 is going to pick up the ball. So yeah, they've got rollers here, and they just kind of drive over the ball, and it sucks it into their claw, and then they go score it. That's kind of a roller claw. It's kind of a different kind of intake. But what they did here is they integrated their launcher into it, so it was all just one mechanism, which was pretty sweet. So yeah, that's a roller claw. Flywheel launcher. You know, flywheels. Usually, you want the flywheel to be heavy. But that's mainly if you're going to be putting a lot of game pieces through it, like we are in the upcoming game that we're going to play at Cowtown. Lots of motor power. Again, more important if you want lots of throughput of game pieces, taking multiple shots all in a row. Need a really good sensor encoder to sense the speed. Requires a lot of prototyping to get right. And shooter ball centering is a thing. This is actually a video I'll probably just play the whole thing. I'll play the whole thing at like 1.5 speed.
I'm your host, James.
And I'm Jun Chen.
Today we'll be looking at whether a single wheel flywheel or a double wheel flywheel best centers the ball.
This is relevant to the 2016 first robotics competition, first run, and the shooter backing back here that serves to support the ball when.
And figuring out which one centers
the ball.
So let's go ahead and run it and see what happens.
So,
now how this would on a shooter, and
so that's
green part is
that's kind of modeling our current shooter, which is 2 wheels. It's kind of backwards because it's not really.
like our shooter.
Yeah, that is modeling our shooter just in a continuous loop. But you can see it. The ball ends up trying to pick one of the wheels to center on.
While we can see what's going on with the ball.
Okay, and the ball here would be that 10-inch one we saw earlier, kind of a mock-up of it. Okay, so why don't we go to a close-up and look at the test that you did and come to some results?
Sure.
All right, so now let's.
So this is This is modeling a crowned roller.
Look at the test.
That crowned roller
as a flywheel.
So right now, the ball is stuck on one corner of the wheel.
So let's go ahead and run it and see what happens. So wow, from what it looks like, the ball seems to be moving towards the center. And now after a couple rotations, if we go ahead and stop it, the ball appears to be in the middle of the roller even though it started out off to the side.
Yes, seems like this roller has successfully centered the ball just by spinning.
Now this is a test of a crown roller, which is basically a flat roller, and if we built up the middle with tape or something, we would get a crown roller. And in this test, we start off the ball off to the side.
Yeah. So let's just run the test.
So after a couple rotations, looks like the ball has actually centered onto the top. As you can see, the gray gear in the middle, that's where the ball is it's in the middle right now. So if we run the tape,
I can slide the paper in front of the ball, and also I can slide the paper behind the ball.
So now as a third test, let's go ahead and test the two-wheeled flywheel. And we're starting out in the ball in the center of the two. So now let's go ahead and run this and see what happens. Okay, so after a couple of rotations, we see pretty quickly that the ball has now shifted over onto one of the wheels.
As you can see, I can now slide the piece of paper underneath just the first wheel, and it's being supported fully by only the second wheel.
In summary, we conclude that the single-wheeled flywheel will center the ball. The two-wheeled flywheel will push the ball away from the center. And for the flat roller, we can make it like the single-wheeled flywheel by building a crown in the middle or a high point in the middle. So that's it. And
So, also, why did I know someone was going to suggest I should become a VTuber? But let's see. So basically, that's kind of what that is showing is we maybe should have prototyped our shooter a little more in 2020. But if we have time between now and we might mess with that a little bit. And also, the thing about being a VTuber is any money I would spend on the model for that would be better spent on the robot team and the actual robot. So yeah. So yeah, flywheels. There are many other like robot mechanisms. There's like 233 arms. Which 233 is the pink team. They kind of have like this, like, you know what? I'll just pull up a video of one. It's gonna be a decade-old video, but it still works. This capture. So you see that pink robot there? Like, it's got kind of like an extendo arm thing. That's what people are talking about when they talk about a 233 arm. It's just a crazy extendo arm. In this case, they put a roller claw on the end of it to grab game pieces. Yeah. And then just general design principle. Keeping weight down is important. We have a weight limit. With the exception of 2019 and 2020, we have always been right on the weight limit. And even if we are under the weight limit, keeping the robot light makes it more nimble and better at offense. And Onshape has an automated feature script to help do weight reduction. That'll be a later lesson. Read the rules. Make sure your designs are legal. Now, RTFM in this case stands for read the first manual. Always think about how you're going to manufacture and maintain your parts. You know, making something that, you know, it's really great, but like one bump destroys it. And it's really hard to make another one and replace it is not a good idea because, again, this is a contact sport. Have other people look at your CAD before you jump into manufacturing. You know, that could be as simple as, hey, Michael, does this look good? Hey, Zach, does this look good? Stuff like that. When in doubt, you have resources. Other teams' old designs. You can Google it. You have mentors you can ask. You know, you're not on your own here. We need to operate as a team, especially with Onshape and being our CAD of choice this year. Hopefully, not going to be in the past where we only have one CAD student. Hopefully, we're going to have multiple people able to do CAD, multiple people able to do manufacturing. We can kind of multi-thread some of this stuff. So what we can do, you know, before, you know, the next season, and set team goals for the upcoming season. That, you know, hopefully by the, you know, the end of, you know, the school year, we'll have an idea of what we're how much we're going to be able to get done next season. So we'll be able to set some goals for ourselves, set some timelines. Because even though if we don't know exactly what we're building, we have a general idea that we're building a robot with multiple mechanisms. You know, potentially a climber, potentially an intake, potentially some kind of scoring mechanism. You know, stuff like that. We can keep our ears to the ground for new products, technologies that we can use in our designs. You know, Rev Robotics is coming out with new control system components. They cost some money. We really need to do some fundraising so we can get new control system components. Because, you know, they're going to allow us to have potentially up to 2 more motors on the robot. Evaluate and potentially design some dry bases next year. I mean, the likelihood we'll probably use something similar to what we did last year and previous, but you know, there are other options. Okay, we're gonna go to Cowtown, so you guys will actually have an idea of what one of these competitions look like. I don't have marbles on stream set up anywhere near, and it'd probably take too long. First and Focus series on YouTube is really good to look at. First Updates Now is like a talk show about First Robotics. I'd highly recommend following them. They also have a Discord you can join. Just warning for everyone: if you're going to, you know, there are First Robotics Discords. If you're going to join one of those and represent our team, remember the team, you know, handbook. All, you know, conduct rules apply. We catch word that you were being toxic in an online community with our team number associated to it, you may get suspended or banned from the team. But, you know, just don't be a jerk and it should be fine. That's really all I had for y'all tonight. I guess, are there any questions that aren't, can we do marbles on stream and will Dylan become a VTuber? You bet I'm based. So yeah, also I guess before we call it an evening, just remember we've got our in-person meeting tomorrow, 6:30 at the school. We've got you know, more meeting. Oh, we've got a CAD meeting Thursday. In-person meeting, I don't know. Hopefully, definitely by 9. You'll have to ask Zach about that one. Oh yeah, and we'll have a programming meeting Saturday. So, but yeah, that should be it. So, I've been recording this to my system the whole time. I'll try to get this up on YouTube like ASAP. So if there's anything that you need to go back and look at, it'll be there because Twitch will only keep the VOD for 14 days. So that's all there is. says, I guess I'll sign off. Thanks for everyone for attending and being everyone that was here on time. Yeah. Peace.